Welcome to Computer Science 322. I hope I'm in the right room. I'd hate to teach a whole class of people the wrong stuff. All right, so my name's David Poole. This is the website for the course. Everything is on the public website. We're going to use Canvas for discussions and grades and clicker registration and nothing else. So everything is on this web page. See what we're doing here for announcements, for assignments, for the schedule. It says what we're going to do after classes. Slides will be posted here. We're using a textbook. The textbook we're using is the second edition of the book that Alan Mackworth and I wrote. Full text is online, so all the text is online. If you like reading online, if you're okay with reading HTML, you don't need to buy the book. There's nothing extra in the book that's not online. Okay, so everything is the complete book is online. All of the chapters are all online, so you can go in there and read that on your computer or your phone or tablet or anything else. All right. Go back to here. Check that out. The other thing is that assignment 0 is due on next Tuesday, and we'll talk about what's going to be in assignment 2 later on today. The discussion and grades are on Canvas, and you need an eye clicker. We're going to do lots of interaction in this class. We need an eye clicker. It's trying not to be an easy class, but you can expect to struggle but succeed. You learn by doing things. You're going to do this time we're going to do lots more programming than we did before. With a whole lot of AI tools in Python that we're going to use that's written deliberately to be for teaching. And ask questions. Ask lots of questions. Let's try and make this as interactive as possible. Does anyone have any questions so far? All right. The marks we're going to do here is we're going to have 30% is going to be assignments. They're going to be approximately weekly. We're going to have lots of small assignments. You're going to do some programming. We're going to try to make them so you can do them in groups. There's a midterm, and the tentative date is this. That's not right. Very tentative. That's not right. It's on. There's a real tentative date on the website. I'll fix this up. And there's a final exam, and the clicker's a bonus. Now you can get up to 4% bonus, and you get 2% for participation, 2% for correctness. And often in the website, we're going to ask people to tell us interesting things they know about topics, and you also get 2% for that. And I'm always surprised at how many people choose to not post and do 2% for correctness. Well, that seems to me to be the wrong choice. The right choice seems to be just participation and give us informative postings, and then don't worry about when you get it right. But some people don't seem to want to do that and complain about that my clicker questions are too hard. I'll ignore those people because they've obviously made poor choices. All right. Any questions about that? All right. First one I'm going to do is a clicker question. There's no right answer. I just want to know what the code frequency is AB. And I'm not going to do that. And what I want to know is, the code frequency is AB. If you forget, it's on the wall over there. And I just want to know whether people know Python at the moment. Oh. There's more people who say no. All right. How many is that? 70. I'll wait for a few more minutes. All right. A few more no's. The no's are winning. All right, good. It's fine. Okay, let's stop that. Let's stop that. All right, the question is, next one is, oh, don't warn again. Close. Is, what's the output of this Python code? If we could show display it. All right, so for the people who wrote, this is as complicated as we're going to get, right? As complicated as we can get. The list of all pairs, we're going to add for x between 0 and 9 such that x is less than 3. All right, this is as complicated as we get. So we're going to hold a tutorial. The TAs will hold a tutorial sometime in the next week or so before the assignment is due, and they'll talk about as much or as little as we need to do. There's lots of resources for doing this, and it's a good time to learn Python. It's a useful skill to have. Okay, let's stop that. So we'll hold some informal tutorials for that. Let's stop that. Okay. Any questions about that? Just stick your hand up and yell if you have questions, or yell. Sometimes I don't notice, so. All right. So what we're going to do today is we're going to talk about what is artificial intelligence, and we're going to talk about this abstraction of agents acting in an environment. And at the end of the class, we should be able to describe what an intelligent agent is, identify the goals, and classify the inputs, outputs of various agents. I'm also going to look at some of the simplifying assumptions that go into building an agent in here. Okay. So here's a definition of artificial intelligence we give. It's the synthesis and analysis of computational agents that act intelligently. So it's all about agents. So an agent is something that acts in an environment. So it can act in an environment. It can be something, it can be a car, it can be an intelligent instructor that actually acts in an environment with students. It can be a robot and a Go-playing agent that acts and just plays games. It can be all sorts of things. But it's about, the aim of this is about acting in environments, and an agent is just something that acts in an environment, something that does something. Okay, so we're actually interested in action in this class. An agent acts intelligently, so now we've got an agent. An agent acts intelligently if its actions are appropriate for its goals and circumstances. It does appropriate actions depending on what it's trying to do and where it finds itself. It's ones that are flexible to changing environments and goals, so we're not just doing, in factories, traditional factories, there are robots that sort of do all the same thing all the time. They paint the side of the car, and if you put something else in front of them, they won't adapt to that changing environment. They won't say, oh, there's not a car in front of me, there's an elephant. They'll just paint it normally. So that's not intelligent. And we're also going to have changing goals. So we're allowed to change the goals of what we're doing. So it's going to be flexible to these. And I want something that learns from experience, that as it goes on, it actually gets better and better at what it does. Okay. And the last one is it makes appropriate choices given perceptual and computational limitations. So normal agents in the world don't get to see the whole world, right? You don't get to see the whole world, and we don't have unlimited time to think, right? We can't sit there, we don't see the whole world and have time to think about how it works, but we have perceptual limitations. You can't observe all the world, and we can't compute arbitrarily long. There are some problems that are too hard. You can't sit and look at the world. With cars driving around, get a snapshot of the world, pretend it's like it, think for half an hour, and then cross the road, you'll get run over. Okay, you've got to think quickly, often, and approximately in order to make appropriate choices in the world. Okay, so that's our definition of artificial intelligence. Are there any questions about that? And they're computational agents because they're ones we're actually going to build in terms of computation, which means we're going to build them in terms of simpler components. We're going to build them from bottom up in terms of simple components that all build on computationally on other parts of the world so we can actually implement them. So we're going to synthesize them, we're going to build them, and we're also going to analyze how they work. And so that's the goal of this, of artificial intelligence is about. So here are some agents. You know, there are lots of types of agents. There are organizations, for example, Microsoft or Al-Qaeda or the government of Canada or the UBC or the CS department. There are organizations that act in the world, and that's one of the parts of agents that people think about. There are people, and in particular there are roles we often think about as people, like teachers, physicians, stock traders, engineers, you know, travel agents, farmers, waiters, and some of these are in more or less automated ways of doing this. Stock traders are pretty much fully automated now. Travel agents are getting much more automated. Farmers are becoming there. You know, waiters are still not there. Teachers and physicians are a long way, and engineers are a long way from being automated. And then there are all of these computers and devices, from as simple as a thermostat to sort of user interfaces that act in the world, that airplane controllers, network controllers, you know, games, advising systems, tutoring systems. You can just think of all of these ones that exist now that have some component of what makes them intelligent. Things like the Google car and the Mars rover for doing this. And there are other animals. There are dogs, mice, birds, insects, worms, bacteria. I know I have bacteria twice. All right. I have bacteria. So now here we have all of these different animals that also act in the world. And then you might even think of under whether a book or a sentence or a word or a letter is. So let's do a little, another clicker question for you to keep you awake. This is one I always get into arguments with people about, so I thought I'd find out your opinion. So I want three answers. A is yes, B is no, and C is I'm not sure. And the first question is, can a book inspire, explain, or enlighten? I can show this. All right, let's see what's going on. So everyone here says the answer. So people here basically say the answer is yes. All right. Whoops, let's click that out. So the next question is, can a book be an agent? Can a book do things? All right, let's have a look at what's happening here. That's interesting. What's an agent? Oh, an agent was something that does something. This is one of the things that people have arguments about whether books can be agents, whether they do things. People seem to want to say here that a book is an agent, can do things, but not be an agent. So I want to include books as agents. I want to say books do things because they inspire, explain, or enlighten. Even though people, because they do things, right? They do things in the world. Shakespeare's books still do things, but Shakespeare doesn't do things. He's long dead. Shakespeare's books inspire people. All right. All right. Let's stop that. The next question is, can a paragraph be an agent? Let's do two questions in a row. Let's do the next one. Can a sentence be an agent? Whoops. Oh, I stopped that. Wait a minute. Stop. Sorry. Let's start this again. Stop. Can a sentence be an agent? Can a sentence do things? right, let's go there. More people think sentences can be agents than books. Oh, well. What about, that's a reasonable sample. What about, let's stop that. Click that out. What about just a word? Can a word be an agent? Can anyone give me an example of a word that can be an agent? How a word could do things? Yeah. Hope? Oh, okay. Yeah. And also things like just right, you can get a word to actually do things in the world. What about a letter of the alphabet? Whoops, let's stop that. Stop. Oh, let's go through here. What letters does the alphabet do? Can we think of an example of that? It seems to me to be pretty obvious that books can be and letters can't be, but I don't know how letters by themselves don't actually do anything, but books can do things, I think. Yeah. R. What does R do? No, it's the name of a whole programming language. All right, it's probably R, isn't it? It's the name of a programming language. The letter doesn't do things. And what does that letter do? If someone sends you a text with the letter K and you end a relationship with them, and they accidentally use the word K somewhere in their text, and you end. They just respond, surely the letter K. Oh, then it's a word. Then it's using a word. All right. All right. This is sort of one of the things that people argue about as to what agents are and what they're doing things. For most, and this is sort of interesting, I think, because one of the things is that they're compositional, so things can be built up. One of the things that makes, we can actually build up intelligent things from non-intelligent things. So this was supposed to be an example of that, but everyone disagreed with me, so I was trying to give an example. We can start off with these non-simple things, these simple letters that aren't agents, and we're going to build them up into more complicated things. And here was an example of where you could start off with simple things and build more complicated things that then became agents and actually did things in the world. And a lot of what we're going to do is to start off with very simple things and then build them up into more complicated ones of doing it. But my experiment failed miserably. Oh well. Let's stop that. Get rid of that. All right. All right. So when we're going to build, what's happened to that? When we're going to build this, we've got a goal, we've got a scientific goal, is to try to understand the principles that make intelligent behavior possible in both natural and artificial systems. So we're going to understand what's intelligent. So in natural systems, things like psychology are doing that. Philosophy and anthropology are all studying intelligent behavior, and economics. In natural systems, we're also, but by understanding how intelligence itself works, we're going to try to understand intelligence itself, and we have the advantage we can actually build systems. We can actually build agents that we're going to argue are intelligent about in there. So we're going to do this by analysing natural and artificial agents. We're going to look at these natural and artificial agents, and we're going to test hypotheses about what it takes to build intelligent agents. So what does it actually make? How can we actually go about building these intelligent agents? And then we're going to design, build, and experiment with systems that perform tasks that require intelligence. We're going to understand a bit about what it is that actually goes about making intelligence. So we're going to people write systems that sort of purportedly show intelligence, and sometimes they get into and sometimes people build the world Go champion because apparently Go is very complicated and requires intelligence, and so people build these systems that actually play that, and hopefully that's going to give us some insight into the nature of intelligence and how to build intelligent systems. So we're going to build these systems that purport to do intelligent things. But there's also an engineering goal, which is just to build useful stuff, right? The Google car people aren't that interested in the scientist's goal. They actually want to build, well, they probably are. They want to build a useful tools for people to use. And so there's these two different goals in this. And one of the things that we can do is to think about this analogy between flying machines and thinking machines, is that people thought about how to build flying machines, and people like Icarus stuck feathers to his arms and tried to flap and found out that it didn't work. And people now build flying machines by understanding the principles behind flying, and actually fly nothing like real birds. You know, they look very different, except when you understand them, you can understand the principles behind them. We now understand how birds fly and how insects fly and how aeroplanes fly, and it's all basically the same principle. And we understood that principle by actually building airplanes. You know, they don't look like birds or fly like birds or flap like birds or insects, but we now understand by studying aeronautics, we now understand how flying itself works. And the idea is one of the things we want to think about is being inspired by aeronautics, of thinking about that we can actually use the same idea to build thinking machines. We're going to study thinking as a problem to solve it. We're not necessarily going to solve it about how humans do it. We're not necessarily going to build it the same way that the humans do it. So think about this as this analogy about aeronautics as studying flying, but we're not necessarily going to do the same way that birds fly, and instead we're going to understand thinking and reasoning. We're going to understand that in terms of by trying to understand how we can actually get machines to think. And hopefully then we'll understand much more about the process of what it takes to think. And so now there's a whole lot of sort of tie-ins between computer science and artificial intelligence and other fields that are sort of studying intelligence and trying to understand the relationship between them. I'm sure there are a number of you in the cognitive systems program, and a lot of that's about trying to understand this interplay between computation and human intelligence. Okay, any questions about that? Comments? All right. All right, so this is the picture of of what we're going to do for an agent acting in an environment. An agent for us now, is a black box, and it does things in the world. So it carries out actions in the world. So that's what an agent does. And the only thing the agent has available to it is its abilities, which is what it's available to do. So what an agent does depends on what its abilities. So if you give an agent abilities or take them away, it's going to change what it does. So it depends. So what an agent does depends on what it can do, its abilities. An agent does depends on its goals or what its preferences are, what it actually likes about the world or what it doesn't like about the world. So as you change an agent's goals, it will change its actions. So that's why it's a function of the goals or preferences. There's prior knowledge about the world, about what it knows before it starts. So you start off an agent with some prior knowledge, and then it receives some stimuli from the environment. It receives some observations about the world, but it could also be pushed and pulled, and other things happen to it. And it also has a history of these stimuli, a history of past experiences. So there's a history of these from the environment, and that's And that's all an agent has available to it. It just has what it starts with and everything it observes about the world and everything it does about the world. That's the only thing that an agent has available to it. And that's our abstraction of an agent we're going to look at. So here's the definitions of those things. So the A abilities are a set of possible actions it can perform. The goals and preferences are what it wants, its desires and its values. So we're actually going to talk, first of all, just about goals, and then we're going to talk later about more complicated preferences agents might have. Prior knowledge is what it comes into being knowing, and what it doesn't get from experience. So it's what we have to program into the system, or what psychologists call in the nature versus nurture. It's the nature of what we inherit from what we sort of get without experience from the world. Animals can walk, right, when they're born, right? Lots of things they don't learn to walk. So horses, for example, learn to walk immediately they're born. So they're obviously not learning that. They haven't got any experience for it, but they've actually it's prior knowledge, and there's all prior ability to walk in there. So it sort of knows how to walk before it starts. And then there's the history of all of the stimuli about everything it's received from the environment, and it's the current stimuli is what it receives from the environment. These are often called observations or percepts about what it's actually getting from the environment immediately. And then there's the past experience about what it's received in the past. These are going to be interestingly different because we're going to talk about later on about when we build these agents about the fact you have to actually have a memory because you have to remember things about the past experiences in order to get anywhere from them. But they're the only things. The argument is that these are the only inputs to an agent. And these are all important in the sense that if you change any one of these, you change what the agent does. If you change its stimuli, what it observes from the world, you're going to change what it does. And notice that it doesn't depend on the state of the world. It only depends on what you observe, because it's all you can do is a function of what you observe. Right? So if two things look the same to you, if you get exactly the same information from the environment, you can't distinguish them. And that's the basis for a lot of what we're going to, the basis for a lot of the sort of the theoretical things about artificial intelligence things is we can't distinguish things. If we observe the same history of things, we just can't distinguish them. Okay, any questions about that? All right. So let's look at this. So let's look at some examples of agents. An autonomous car. What can an autonomous car do? It can only do three things. What can you do? What can the car do? Do three things, is my claim. What it could do. What can a car do? Yeah. Yeah, it can accelerate, brake, and turn. There's only three things it can do, right? Cars are pretty simple, right? It can steer, it can accelerate, and it can brake, right? They're the only three things. What? Yeah. Well, you could say it's part of the steering, but we'll get rid of turn signals are only useful for now. But at high level abstraction, these are the only three things it can do, right? They're sort of pretty simple, few number of actions in there. What are the goals of an autonomous car? What are goals could have? Yeah. Right, reach a destination is a good goal. What other ones are there? Yeah. Don't crash. Okay. So here I had things like safety, get to destination and get there reasonably quickly and reasonably without, timeliness is another example of a goal that a car might have as to what it's going to do in there. There are actually lots of different goals that you might have for a car. But these are the ones that we're going to think about in here. What sort of prior knowledge would an autonomous car need? Right, so it's going to... What sort of prior knowledge would you need? Yeah. Okay, the rules of the road. What else? Hang on. Let's look this. Hang on, more. This is prior. The rules of the road. What else? Okay, maps. What else might build? What else might you need to build into? Yeah. Okay. Defensive driving strategy. Defensive driving strategies. So a whole lot of these are actually built into these systems about how to actually go about. People program them, how to program out driving things. What other ones? Yeah.
It needs a model of itself, like if that accelerates, it drives.
Yeah, it actually doesn't do that. It doesn't have that in it. What I said of what the road signs mean, what we should stop for. I talked to someone over the last conference I went to, and they were working for this, and their job was to work out, to recognize birds, because birds are actually apparently things you don't want to stop for. They have all these problems with when birds land in front of it, says, there's something in the way, and so it slams on its brakes. There's all these funny ethical things now about what to stop for. What's it okay to run over, which people who are doing COGS would know that this is one of the things they talk about there, but it's one of the issues that you have to worry about when we're building autonomous cars. What's